Currying is an advanced concept in functional programming where a function which should have multiple arguments is broken down into a series of nested functions, and each of the function gets one argument. So we've seen a rise in functional programming recently or in the recent years, and so does the popularity of currying also, and it is possible in different programming languages, not just JavaScript. So let's see an example. We are going to create a function that have multiple arguments. So function add a comma b comma c, and we return a plus b plus c. And when we console.log add, let's invoke it and we pass 7, 10, 21. You can add any number you want. So we save and run the code. So we get 38. Welcome to this video, and please subscribe to the channel and ring the notification bell. It means a lot to me. Now we can go ahead and use currying for the task. Okay, so now we take this function add and break it down in such a way that add receives only a as a parameter. Then another function inside add receives b as a parameter. Then another function inside that inner function receives c as a parameter. Then in the body of that inner function, we are going to return a plus b plus c. So now let's go ahead and do curried add. So we'll say function curried add. Okay, we'll pass a, right? Then inside the body, we return an anonymous function. Okay, that is a function without a name. And we pass to it b. Then in the body, we return yet another function. Return function. And we pass c to it. Then in the body, we return a plus b plus c. Right. So now to invoke this, we come out here and say console.log curried add, and we invoke it. Then inside it, pass let's say 7. Then we come outside. We are going to be invoking each of the nested functions separately. Okay. Now we'll pass 4. Oh, I should not do this. We'll pass 5. So we save. When we save and run the code, what do we get? We got 16. Okay, so we can also go ahead and invoke the function like this. So instead of invoking it, for you to really understand how it works, okay, we are going to invoke all the functions separately outside. So we said let's add 1 equals the curried function itself. So we see curried add 5, right? Then we say let's add 2 equals add 1. Then we pass a value to add 1, an argument to add 1, which is, let's say, 13. Then we now say the output should be equal to add 2 Now we are going to invoke add2 right now. And for add2, let's pass 9. So we'll say console.log output. When we save and run the code, we get 27. Okay, so using currying, we have taken a function that should add 3 arguments, and we've disintegrated it into the curried function along with the 2 nested functions inside it. So instead of having a single 3 arity function, we have transformed it in such a way that it returns a function holding 1 argument, which in turn returns another function inside it with a single argument. And inside the body of that inner function, we are able to perform the task. So when we say arity function, like I said, when we say arity simply refers to the number of arguments that the function accepts. So in our case, with these 3 arguments, we can call it a 3 arity function. So we can also create a curried function using arrow functions. So for our arrow function, we are going to say const arrow curry. Let's use arrow curry for the name. Arrow curry is equal to, and we are going to be multiplying the output of this one so we can get a different result. So let's say x, y, z. So to return it, we are going to say x multiplied by y. Can't find my y button. Multiplied by z, and that's it. So when we come down here and console.log it, what do we expect to see? Arrow. Then inside it we say 7, right? 7, say 4, let's say 5. So what do we expect to see? 7, right, which is the argument of the first function, okay, which is passed to arrow function itself. 7 multiplied by the argument of the second, of the inner function, the first inner function inside arrow curry, which is 4. 7 multiplied by 4 is 28. Then we multiply that 28 by the argument inside the innermost function, which is z as a parameter. Now we pass 28 multiplied by 5, we get an output of 140. So let's save, and what do we get in the terminal? We get 140, as you can see, 140. Now remember, currying does not call the function, it simply transforms it. So you can also go ahead and break down the invocation of this function. You can break it down like we did with the curry add, by breaking it down, let something else equal to arrow curry, then you break down the inner function, then the innermost function. So why do we need currying in functional programming? Currying helps us to write code in models. So by structuring our code in such a way that the output of one function directly links to the input of the function inside it, okay, and this makes it easy to read and reuse, and it removes the stress of having to repeat arguments every single time we want to use the function. So it is also very useful for event handling and so many other things. So in a nutshell, currying is made possible due to scopes, right? And what that means is that even though the functions are nested inside each other, like we have here, okay, the inner function has access to the variables inside the scope of the outer function. So this first inner function has access to the variables inside the scope of this main function. Okay, so whatever variables we create here, this inner function has access to it, but not the other way around. Curried does not have access to the variables inside the body of this inner function. Then this innermost function right here also has access to the variables in the scope of this first inner function, which also allows the innermost function to have access to the variables inside the scope of the outer function. Okay, and I know we haven't talked about scopes yet, but I'm going to make a video on them. And I know, as simple as it may seem, it is very hard to wrap one's head around the concept of currying. So I'll be making videos very soon as possible, on the concept of higher order functions, scopes and closures, and some of the other concepts of functional programming. And I can assure you there is a lot to learn about currying. So when we do all those things, you're going to know more about currying. So please, once again, subscribe to the channel and ring the notification bell. Thanks for watching, and I'll see you in the next video.